Alright everyone, welcome back to the channel. If you'll remember from the last video, we were working on a Heathkit. This is a Heathkit AR15 AM/FM solid state stereo receiver. For those of you who thought this was a AR15 rifle, I hate to disappoint you, but that's not what the video is about. For those of you who are interested in the restoration, as you can see, a lot of progress has been made on the radio. It's for the most part all put back together, and I've got the camera. I'm trying to doing some filming from a tripod just to keep the camera a little bit more steady. But I will here in a little bit take the camera in, and we'll get a little bit try to get some closer shots of the details, for those of you who want to see. But I'm going to go through here real quick just some of the things that have been done. And then we'll take a look at some of the initial testing that the manual calls out, and we'll go from there. But as you can see, obviously, aside from the front panel being on now, we've got new parts installed on the top. Our first item here is our new high voltage filter capacitor here. This replaces the large blue 8,000 microfarad capacitor that was here, and this is comprised of four 2200 microfarad capacitors. Each of these is rated at 100 volts. The original part was 8,000 microfarads at I believe 90 volts, so this will make it more than adequate for the capacity. And our second part here is the new output section for the power amplifier. We've got our inductors mounted here to the terminal tie strip and new 4700 microfarad capacitors, and these replaced the two large can capacitors, which were these 4000 microfarad 50 volt DC capacitors, and these were mounted here. Still got the leads. I haven't hooked up all the leads yet. There's the manual calls out for the once you complete the assembly, there's 14 leads that are still left disconnected. These are two of them. I'll flip the unit over here in a minute. We'll take a look at the back side. But real quick, I'm going to go ahead and take a look at the front panel. We'll see how that looks. Alright, I've got the camera off the tripod now. I'll try to move a little bit slow and keep it steady here. But here's our front panel. As you can see, it turns out really nicely. The knobs I still got a little bit cleaning. Need to try to get some of this gunk out of these grooves. It's really pretty difficult to get the dirt out of there. Those grooves are so fine. But anyway, so that's a little bit of work. And I haven't mounted the knobs here either. But everything else has been put back together. We've got the knobs in here and the trim pots for all of the different level adjusts down there. And our switches here on the front panel, and these are already set up for the initial tests that the manual calls out for. We'll look at that in a minute. And just take a closer look here at the work on the filter capacitors here. This is our four 2200 microfarad capacitors that are in parallel to replace that big blue can that sits here. And then these are the output capacitors here that go into that feed the inductors and then ultimately go out to the speakers. And of course, these are the leads that will wire into here to the positive side of these capacitors. And they were really short, and I really don't like to splice, but you know, sometimes you got to do that, and that's what I've done here just to give some more lead length. The tuner board still here, a little more cleaning on the tuner board, and the dial of course has been restrung. And I got to read in the manual, and it turns out that you don't really need to unstring the dial to open the tuner section. What it has you do is it just has you take the pulley off of the tuning dial, and I've already done that. It slides off pretty easily, and then you can open the hinge cover. All right, I'm going to turn the tuner over now. We'll look at the bottom side. Okay, here's the bottom side of the tuner. As you can see, we've still got some leads disconnected, and what it is these are all of the leads that take the power from the power supply to the various boards, and the manual has you leave all of these disconnected, as well as it has you leave the 80 volt DC that goes to the output transistors. That's disconnected, and that's what this red lead here is. When we get ready to connect all of this up, these will tie into this tie point right here, which is an isolated tie point, and that's where this lead and the lead from the power supply will all tie in for the filter capacitor here. I've already gone ahead and hooked up this little jumper to the meter switch, which is here. And that has you hook up a jumper onto lug 3 of the meter switch, and it has you set it to the R position. And what the manual does is it has you power up the tuner, and it has you do resistance checks. And I'll show you how that works. And I'm not going to do them all on camera, but we'll show you. We'll do maybe one or two of them just to kind of get a feel for it, and then we'll go through, and then I'll go through the rest of them. And if all the resistance checks check out good, then we can proceed on with the final wiring. One other thing that I did was I replaced the line cord, and the tuner still had the original line cord on it, and it was a non-polarized cord, so I went ahead and changed that out for a polarized line cord. So after the assembly of the tuner is complete, there's a portion in the manual here called initial checkout. And that's what I'm going to go through here. It basically has some general stuff. First thing it has you do, well, the first section here is it breaks down the initial checkout portions. There's an inspection, resistance checks, which is what I'm going to do next. Then there's the final wiring. At that point, we'll wire up all of the voltage, all of the power supply leads to all of the different sections. Then we'll do voltage checks. And what it has you do is it has you use the built-in meter. And then after that, there's a hum injection test, which I believe just consists of using like a screwdriver and just tapping various points in the audio chain and listening for a noise on the speaker. And then after that, at that point, I think all of it's done, and it will go into the alignment portion. For the initial inspection, I've gone ahead and made all of the control adjustments into the correct positions, and there's some more on the back side here. There's switches and some controls, including there's controls actually inside the radio. The signal meter's function switch, which we looked at, was set to resistance. The 19 kilohertz switch, which is the switch here on the top of the tuner board here, set to norm. And finally, the AM meter, which is an adjustment on the tuner board here also. This AM meter right here, this is a potentiometer under the board, and it has you set that full counterclockwise. That's already been done. Other than that, I've looked over this unit. I haven't found any obvious problems. Hopefully nothing catastrophic happens when we power it up, but I'll hook it to the isolation transformer and we'll run the voltage up slowly, look at the current as it's coming up. But anyway, once we do all that, what we expect to see is all of the lamps to light up here. And it actually talks about it here. Here's where it tells you how to hook up the little test clip there to the meter selection switch. And here's where it spells out the leads that will still remain disconnected. Two of the leads, these two blue leads here, are this is 100 volts AC coming out of these transformer leads. So if you do this, make sure that you take the appropriate precautions. You need to make sure that you don't electrocute yourself, because that's a high voltage coming out of the transformer there. And we see the filter capacitor positive, the red, where the red leads will go here, still disconnected also. And here is the procedure that it's going to have you go through. So we'll plug in the unit, turn the power switch on. We expect the high temp indicator to light, and that's because if you look at the schematic, the this transistor here in the power supply actually controls the high temp light, which is here. And the way this works is this transistor is biased off when a high temperature condition is not present. And the way it determines that is it looks for voltage on the amplifier side of the thermal circuit breakers, which are on the heat sinks. So if one of these circuit breakers opens on a high temperature condition, say just for normal operation, then that will remove the high voltage to the output transistors, and the loss of the voltage here will cause this transistor to turn on because, as you can see here, it's a PNP, so it's normally going to be biased. The base will be biased low with no voltage present here, so this transistor will turn on and it will light the high temp light. Now, the way this the unit is hooked up is set up now, where it's not completely wired. These red leads here from the power supply that goes to the pass transistors is not connected, so there's no voltage on this line, and so for the circuit just assumes that one of these circuit breakers is open, so that's why that light's going to light. When we finish assembly, as long as these circuit breakers are closed, this light should remain dark. Looking back at the procedure here now, and we just talked about this node here, the high temp indicator will be lit, and also we would expect to see the other lights on the front panel lit as well, so we'll look for that. And then once you've got it turned on, it basically has you go through, and with your test clip, you're going to test onto the metal chassis and all these points on this list, down the list, and you're looking for these indications on the signal meter. And we'll look at that. We'll see that when the unit's powered up. But, this back when this was a kit, a lot of people that were putting these together may not have had test equipment like we do today. It's pretty commonplace. So this was one way that Heathkit could make a dual use of the signal meter here on the tuner to help the builder sort of check their work to make sure that everything was wired up correctly. Because you spend a lot of money on a kit like this and you don't want to burn it up because you wired something up wrong. Nowadays, everybody that does this sort of thing has got ohm meters and voltmeters and dBms and whatnot, but it doesn't really specify what a correct resistance value is. So at least for this portion, I'm just going to do this section because it does tell you what the meter should indicate. Now, when we do the voltage checks, I'll probably skip the using the signal meter to check the voltages, because I can check the voltages with a voltmeter, and you can look on the schematic and see what the proper voltages should be. But we'll work through this part first, and then we'll go from there. All right, so I got the tuner plugged into the isolation transformer, and we're looking at the current, the output current here on the meter. So I'm going to go ahead and turn the tuner on. I've got the AC voltage set to about midway, so that it shouldn't go too high. But if there's some sort of major fault, we should see the ammeter peg up, and we can turn it off. The fuse is also fused, so hopefully if there's some major problem, the fuse would catch it. But I'm going to go ahead and turn the tuner on now. All right, we see a little bit of jump, but nothing significant. So I'm going to go ahead and raise this up all the way to my little mark here, which should give us about 120 volts. So there we go. So we're looking at about 250 milliamps of current draw here, and with the radio in this condition. And as we can see here, we see that the tuner is indicating that all the lights are lit up. So I'll turn this lamp off here. Now we can kind of get a better idea of the front panel here. So it's all lit up like we expect, and of course there is our high temp light, which we talked about, and we expect that to be lit. And the unit's set to the phono position, which is the position that's called out for. All right, here's our signal meter right here. This is what we'll be using to do our voltage checks. And I'm going to go ahead and do that now. First one I'm going to do is I'm going to take the clip, which is right here, and I'm just going to clip it to the chassis because that's the first one it calls out. And we see that our signal meter now is indicating 5. So we hooked our test clip onto the metal chassis, and the signal meter should be showing 5. So that's good. We've got the first indication there. That's correct. The next one we're going to do is we'll do the blue wire, which goes to the control preamplifier. So this is the harness that comes out of the control preamplifier, and a lot of these leads here, the color has sort of washed out and they're really hard to see, but I've been able to trace them out. So this is the blue lead, and it's still sort of blue. We'll clip that on here. And for the blue lead, we're looking for somewhere to 1/2 to 2, so somewhere in this range for the needle to be. And there's our signal meter here. We're sitting at looks like 1.5, so that looks good. 1.5, 1/2 to 2, so we're good in that range there. And we'll do one more just to kind of go through it, and then I'm going to finish up the rest of them, and I'll let you know if we find any problems. So I'm going to go to the red wire on the power amplifier cable assembly. So the power amplifier cable is this assembly here, and this red wire is this right here. And for the red wire, we're looking for 1/4 to 1 1/4, and sitting there right at 1. So right somewhere in there, so it's just right there at 1. All right, so we've done 3 of these checks, and you kind of get the idea how this works. It's pretty simple. I'm going to go through and finish them up, and then I'll let you know what the results were and if I found any issues. So all of the resistance checks were completed and didn't find anything that looked suspicious. So the next thing that the manual has you do is to perform the final wiring. And I'm just going to summarize what that entails. It's going to have you basically attach all of these leads, and these are the leads that you check on the resistances. And they all go to these power supply terminals here. And then, of course, this red lead here, which goes to the main filter capacitor here, and the 2 blue leads here that provide the power to the voltage regulator. All right, all the low voltage connections have been made now to the power supply. And I'm just going to go through one more time now. I've got the radio powered on, and we'll check all of the voltages to see make sure we're getting readings that look to be correct. So the first thing I'm going to check is the 12.7 volt power supply. And it looks like about 13 volts. That looks good. And we'll check the 12 volts that goes to the tuner, which is down here, and this one just goes through a drop resistor, so maybe a little bit high, 13 volts. Yeah, that's just not really load there yet. The next one we'll check is a 15 volts that goes to the FM tuner. And we got 15 volts, that looks good. And then we'll check the 27 volts that goes to the preamp and the power amp. So 26, that's pretty good, that's close. And then finally the 50 volts that goes to the phono preamp. There's 50 volts there. And of course we've still got our 80 volts that goes to the output transistors right there. So all those voltages look good. So the next thing to do is going to be proceeding on in the testing procedure. Alright, so I've been through all of the voltage checks and everything checks out good. What I ended up doing was I went ahead and hooked up the signal meter again to do the meter, and I just double checked. I used the meter to double check with what my DVM actually showed for the voltage values, and everything I found on here, the needle indicated correctly on the meter reading, and then I wrote down the corresponding voltages. And also, so here's some more of the voltages for the amplifier, and the this is the FM. This is the, I believe, the multiplexer there, and then the there's the preamp there, and then the phono and the tuner section, and then the rest of the tuner section is there. So those are the voltages I got, and you know they all corresponded to what the schematic said the voltages should be. The schematic's got the voltages you can see right there, Q101. You see the little number in the bubble. That's a voltage reading, and all the voltages that I've read from these components corresponded to what the schematic said it should be. So what I want to do is I've got a speaker under the cabinet, or under the desk here. I'm going to hook up with these leads, and I'm going to see if I get any signal. I'm going to take this jumper off first, but then I'm going to hook up the radio. I don't have an antenna, but I'm going to hook up and see if I can pick up anything. Maybe connect like a long wire or something to the FM antenna. See if I can pick up something local. All right, I've got the radio powered back up now, and it's hooked to this speaker down here, and I believe it's on the left channel, so I just have the one speaker. And we're on FM, and I just got some test leads hooked to the FM antenna. I'm going to see if I can pick up anything. I hear some static on the speaker, so that's good. Yeah, it went away, so I hear some static. Sounds like it needs. I hear that beating sound, and it sounds like it's going to need an alignment. Pick up something. Yeah, there's definitely a voice in there. All right, there we go. All right, there's something. All right, so here's the FM tuner, still doing the same thing with that pulsating audio sound, but I switched channels to see if maybe it was isolated to one channel. So now I'm on the right channel, and as you can hear, it's still doing that pulsating sound. So I think let's see. So I think the next thing I'm going to do is so obviously we have some kind of problem with the tuner section, and it's kind of odd to me because it's it does the same thing on AM and FM. And I can't. And looking at the signal path through the tuner section, there's the only common portions that the AM and the FM share is the audio. So from the preamplifier onto the power amp. So it's kind of odd. It could be a power supply problem. So we'll look at the power supplies and see if there's some kind of something going on with the power supply. But one thing I want to try, when we can look at the audio chain, is I'm going to see if I can inject a signal into maybe like the aux jack, and we can see if we can, because that'll allow us to test the audio portion all the way from the preamp all the way out to the power amp. So I'm put just a test signal into the aux jack, and we'll see if that same pulsating sound is still occurring in the audio section. Well, here we are, and here's where I'm going to leave you for this video. Just follow up on progress so far. I've got the radio powered up, as you can see, and I'm injecting a 200 millivolt signal into the aux input, and that's because the manual says that the minimum input should be 200 millivolts. And I've got to switch to mono right now so that both channels will be putting the same signal in. And with the oscilloscope, I'm clipped to here on channel 1. I'm clipped to the output of the preamp is Q105, and this one is Q105L, which, if you look at the schematic, is right here at the emitter. So this is going into the power amp, and I've already checked the signal at Q105R, and it's the same signal, and that's what this this sine wave is right here. This unclipped sine wave, and as you can see, it's got a so 200 millivolts in, and we're getting about almost 1 volt peak to peak on the output. And we see that the second trace here, the one that looks clipped, is attached to the output of the right channel, I believe, is this one. And I've got that hooked to a speaker. I'm sorry, that's the left channel. So we're hooked to a speaker to the left channel. And I'm going to turn the speaker on here in a minute, just kind of show you what the output is doing. But anyway, basically, if we turn the volume down, I've got the volume turned all the way up right now. So if we turn the volume down at some point at a lower volume, the output becomes undistorted. But you can see that it gets distorted here at full volume. And when we turn I'll go ahead and put this back at full. When we turn the speaker on, we can see that the output there drops down to a very low value. I'm going to turn the speaker off. So anyway, you can see that we basically have no output, no drive on the output. And what's odd is that it does the same thing on both channels. So, like I said, I've got my oscilloscope hooked up here, and we can see that, with the speakers turned off, there's still some distortion at higher volumes, but when we turn the volume down, the distortion goes away. But when I turn the speaker on, it drops to a very low level, and I've calculated the values, some really low, like not even a watt of power coming out. And it does it on both channels. The same thing. The other channel, which so we're on the left channel. So the right channel, There's also some ringing in the output that's not present on the left channel, so that may be another problem. But and it could be my speakers. These are old speakers, and I've actually ordered some new speakers. They haven't got here yet, but when I get the new speakers, I may try and see if it's the speakers maybe. But these are 4 ohm speakers, and so there's no reason why this radio shouldn't be able to drive these speakers. But anyway, so I'm going to leave the video here. I've got some notes. I'm going to go back and read the manual some more. Try to get a sort of better understanding of how the output section works. And after that, I'll probably be pulling these boards out and doing some more, probably checking the individual components to see if there's something that may have failed. It's like I said, it's kind of odd that both channels are doing this. That would seem to tell me to think it's somewhere down in the control preamp, but we're getting good signals out of the preamp, so it's somewhere in here. And I've also I'm not going to show this on the video, but I've also just removed this lead here and injected a like a 1 volt peak to peak sine wave like I'm doing now, and you get the same response. So I know that it's isolated somewhere to this amplifier. I did all these voltage checks, and a couple of them were questionable. I mean, some of these, like this 7.9 was reading somewhere around like 8.5 volts, which again isn't, maybe not something that would definitely point to like a smoking gun per se for failure. But one that did interest me, and it's on both channels, is this driver emitter here, which says it should be 41.5 volts, and the same thing on the right channel is 41.6 volts rather. And on both channels they're reading 32 volts, so 10 volts off. So there could be something that's failed in both these channels. I know the driver transistors here and here. I've put brand new transistors into all of these, and I didn't find any original parts. It's 40411, but what I did find was an NTE 181, which cross-referenced as a suitable replacement. So that's what I've got. I got 4 NTE 181s installed, and I was able to match them on the curve tracer over there to get them not perfectly matched, but get them matched within pretty close tolerances. So I know these transistors are good here and here. Like I said, I'm going to be taking these boards out and probably checking each of the components individually. My initial suspect is going to be somewhere in this portion down here, which is for the negative going signal here, because we had the voltage that was 10 volts lower here than what is listed. And I'll be checking these power resistors to see if maybe they've drifted in value or whatnot. So anyway, I'm going to leave the video there for this installment, and hopefully here in a few weeks I'll be able to get some more progress and get an update to this repair. That's all. Thanks for watching.